Hi, Wayne. Thank you for joining me today on the Net Zero Compare podcast.
Hi, good to be with you.
My pleasure. You have spent more than 3 decades working across sustainable and regenerative business, innovation, and leadership. You're a fellow and head program instructor at the University of Cambridge Institute for Sustainability Leadership. Also, professor of practice in regenerative business innovation and technology at Cattolica Porto Business School, and the author of more than 40 books, including the international bestseller Thriving. But today, I'd like to focus mainly on your new book, Technologies of Hope and Earth-Saving Mission. In it, you look at which technologies are already delivering real environmental benefits, which are becoming commercially viable, and which may still be receiving more attention than the evidence justifies. I think that matters for businesses because climate technology decisions now affect more than sustainability themes. They influence investment, energy procurement, supply chains, product development, compliance, risk, and I would also say long-term competitiveness. So I'd like to really explore how companies can separate real progress from hype and greenwashing, where the most important developments are happening, and also what decision makers should realistically be doing right now. You have worked with companies, universities, and sustainability professionals across many countries, including through your work at Cambridge. So, how did those experiences shape the central argument of technologies of hope? And also, what convinced you that this was the right moment to write a book focused specifically on technological solutions?
That's a good question. And I guess most of my career, 30 plus years working in sustainability and mostly working with companies, inevitably it's an occupational hazard. You spend a lot of time finding evidence about the problem. And at some point you feel impatient for the solution. And so my focus began to shift, even while I was at KPMG running their sustainability services, to really look at what can bring us as fast and at the scale that we need on solutions. And of course, innovation becomes a key there. And so my last book, Thriving, what I was trying to do is to make it understandable for people, especially in business, how we could apply systems thinking and the innovation lens to turn potential breakdowns, of which we have many, of course. Climate breakdown is one, but we also have nature, we have social and economic breakdowns. How do we turn those into breakthroughs? And as I was researching and writing that book, I just came across so many examples of great technologies. And so that's done very well. But at some point I was then asking the question, are all of these technologies really going to get us to where we need to go? Or are some more viable? Are some moving more quickly? And that's when I started to think about technologies of hope, to really look at which would move the needle. I also decided in this one to focus really on the environmental technologies, whereas Thriving, I also looked at the social and the economic. And it allowed me to distill down some of those technologies to what I think are the potential winners.
Thank you very much for that introduction. My first impression, to be honest, when I was reviewing the manuscript that you shared with me before our conversation, was that your experience gives the book a very strong practical foundation. Because rather than looking at technology in isolation, you connect it with markets, leadership, policy, and real-world implementation. Probably that's why it's so relevant to our audience. So let's start with the main idea behind the book. The word hype can sometimes imply optimism without sufficient evidence, but you make a clear distinction in your book between passive optimism and hope grounded in action. So what criteria must a technology meet before you consider it a genuine technology of hope, rather than, let's say, interesting experiment or an attractive marketing story?
Yeah, and that word hope is so interesting because I sometimes say hope is a scarce resource today, but it is a renewable resource. And it's something that we all need, especially the younger generation. But it can't be that blind optimism. It can't be sort of false hope. So it has to be grounded in an expectation of action. But to look for criteria of which technologies to include, there were really two big things. One was, does it have the transformational potential? In other words, if we were to really implement this and scale this, would we get, really big shifts towards net zero and nature positive? And the second criteria was really, is there evidence that we're already on the pathway of exponential change? And that's both in terms of growth in deployment of the technology and alongside that, rapidly falling cost curves. So, these were the criteria I really looked at, the potential, but also whether it's already getting traction and starting to scale.
Also, as we know, many technologies attract attention early on, but far fewer become affordable, reliable, and scalable. That's the main problem. So, what made the technologies in your book stand out from the rest?
Well, you have to look at the trajectory that they're on, and I've done a bit of work with the think tank called Rethink X, and I've always been quite inspired by their work. And what they've done is they've analyzed technologies throughout history, hundreds of technologies, and what they've been able to do is to plot an adoption curve where the new technology is adopted, and that's an exponential rising curve, and also where the old technology goes into decline, and that's an exponential falling curve. And these two, cross so that you end up with an X curve, hence their name, Rethink X. And so, for me, that was really what I was looking for. Which of these technologies appear to already be on those trajectories? I study also, as I mentioned, systems thinking, and there's that critical idea of a tipping point, that's the inflection point at which things go from slow adoption to suddenly very rapid adoption. And, I think all of the technologies that are featured in the book, and overall there are 20 technologies, all are on different stages of that adoption curve. To your point, it's really important when you call it a success or a failure. Some are already extremely clear that they're beyond the tipping point. Others, I think it's too early to call, which means they could still fail, but the indications are that they're on the right trajectory.
You've mentioned that the book covers a wide range of technologies. I even listed from solar, wind, and battery storage to low carbon materials, alternative proteins, earth information systems that we've already mentioned as well, even robotics, and very popular nowadays, AI. So how did you decide which areas to include, and what evidence did you look at to judge whether they could make a meaningful difference?
Well, the areas to include, I think I did a little bit of, thinking from the end point backwards, meaning that we have to ask ourselves the question, which sectors of society need to transform if we're going to have a hope of getting to net zero and nature positive. And of course, the biggest is the energy sector. And so that had to be in there. But then there are other very significant sectors like the food and agricultural sector, like the hard to decarbonize materials sector, and others. So, I just tried to look at the economy and say which changes are needed to move the needle. others like Bill Gates, for example, in his book, do quite a good job on this as well, really taking it sector by sector. And so that's how I chose which sectors to look at. And then within those sectors, which technologies. I guess I started again looking backwards in the sense that you got to look at which have the potential to be transformational. It's no good scaling a technology that in the end is just having incremental improvements. And then doing a kind of feasibility test on them. So yes, they could radically reduce carbon emissions, 85, 90, 95%. But then where are they on that adoption curve? And the key indicators to look at there were always, of course, market adoption. Sometimes that's early. You've got to look at venture capital. And then the other one is cost curves. What's the cost per unit and how's that been changing over time?
This is what exactly our customers and clients are looking always at, which is cost, performance, real-world adoption, and measurable impact. In your book, you also discuss how emerging technologies often move from a hype cycle, from, let's say, inflated expectations to disillusionment, and eventually, in successful cases only, productive use. So if you could tell us, how can businesses tell whether a climate technology is moving toward a genuine commercial maturity or simply benefiting from temporary hype? Let's say generous funding, which is ubiquitous in that field, or simply green marketing?
Yeah. Well, I think the clue is partly, what is the narrative around the technology, and then what is the performance of the technology. So the narrative, one way to test is to ask the question, is this technology, as it's being sold, promising to solve everything? Yeah. Is it being sold as a kind of silver bullet? If it is, if it's this kind of wonder technology that everybody's raving about, it's probably still in the hype cycle, going up that peak to the peak of inflated expectations. If, on the other hand, it's already we're already discovering that it is a fantastic technology, but it has serious limitations. And those could be policy constraints, those could be actual performance, or simply that it's not as applicable to as many cases as we thought it would be, or maybe not as applicable to as many geographies as we thought it would be. And then the question is, do you start to see it moving up the plateau or the rising plateau of productivity? And that's simply, is it delivering what it promises to deliver? So, if it's a technology that promises to reduce carbon dioxide, as we're seeing it deployed, is it doing that? Is it achieving the kinds of promises that it set out to achieve? And fortunately, on a lot of these technologies, the evidence is there. So it's partly to listen and to look at critically at the narrative, and then to dig into the actual performance numbers.
So over here, I would say that transparency is the key, because without the transparency, then we wouldn't be able to make informed decisions. And what warning signs should procurement teams, let's also say investors or sustainability leaders, watch for? Red flags, maybe what we've just mentioned, is it just the hype or something else?
Yeah, I think for investors and procurement teams, what I would say is, if they're wise, they do need to not take a snapshot perspective. They have to take a medium to long-term perspective. And the most helpful way for them to look at it is to say, what if there was a genuine price on carbon or a genuine price on externalities in nature? And, the expectation should be that will come. I mean, it exists in in a messy way already, but it's absolutely undeniable that climate change will get worse before it gets better, and that the pressure to internalize those costs to society and the environment will just get bigger. And so, irrespective of the geopolitics today, both governments and businesses will be forced to start to pay that price of carbon, and the price will go up. We know that for sure. So I think for investors and procurement teams and others, it's just to look at, does this solve the problem we're trying to solve? And if the costs are still higher than the competition, can we see the costs coming down so that within a few years they will be cost competitive? And, that's been the case, of course, in all the renewable energy technologies, which are now below the cost of fossil fuels. But it's also been true with electric vehicles. We've seen those costs coming down. And depending on where you are in the world, that's either reached parity with fossil fuel cars or very shortly will. And so, I think that's the way to think about it.
I do agree. Also, this is exactly what I've been discussing with my previous guests. And also, this is probably a good moment to remind that the technology can look promising on paper, but still be a long way from working reliably and affordably at scale. And I would say that this gap is especially clear when we look at the energy systems. Solar and wind have become much cheaper and are being deployed quickly, especially solar, I would say, while battery storage is helping make them more reliable. But businesses still face grid constraints, permitting delays, infrastructure gaps, and concerns about consistency. So my question would be, how close are we to an energy system where solar, wind, and storage can replace a significant share of fossil fuels? And also, if you could tell us what practical barriers are still being overlooked in your view?
Yeah, I think we're very close, if not already past that tipping point. Of course, it's messy and it varies by country, by geography. It does depend on how well the government is supporting the effort, how quick the existing technology companies, particularly the grid companies, are keeping up. But the adoption rates are mind blowing. They're going so quickly, and perhaps in Europe, I think we're both sitting in Europe. If I can still say that the UK is part of Europe, but we're in this region where perhaps we see more constraints. We see governments going a little bit more cautiously. They're a bit more locked in to the fossil fuel system. We've got a live debate still in the UK about whether we should, reopen North Sea gas drilling. But actually, if you look at the trends, it's the emerging markets where this is going extremely fast. And in many cases, they're leapfrogging straight over the West. Because, of course, they're not as locked into the old technology, but also it's a matter of survival, right? We've had two wars, the Ukraine war and the Iran war, and both have been catastrophic for the price of fossil fuels, and that simply makes renewables even more competitive and even more resilient in terms of not having to rely or expect these shocks to the system, to the prices. And so, as I say, it's messy, but that doesn't seem to be slowing down the adoption rate. And I do think all grids can cope. They need to be updated at the same time that we're deploying. They do need to be upgraded. I think the bigger barrier that you already mentioned is kind of political barrier. sometimes that's because of the fossil fuel lobby. Sometimes I would say it's even because of misinformation or misunderstanding. The idea that we need to keep lots of fossil fuels as backup because of the intermittency of renewables, is not a really good reason, since, battery technology has got to the stage where it has and can replace those fossil fuel plants. But also it's just the bureaucracy of it, getting approvals to these and dealing with local resistance. The difference with oil and gas is it's often far away. It's on somebody else's land, or it's out in the sea where nobody can see it. Whereas often solar and wind are local. They have local, if not nothing else, aesthetic impact. So you also have to get over that NIMBY phenomenon, not my backyard. So government has a very important role to play.
Got it. Also going back to the solar energy that you mentioned at the very beginning, I saw a graph chart yesterday with all different predictions that they made 10 years ago regarding the adoption of solar energy. Worst case scenario, the best case scenario, and the actual adoption is way better even than the best case scenario that they predicted 10 years ago. So there is a lot of positive stuff going on over here, that's for sure. And if I understood correctly, the transition requires grids, storage, transmission, planning. What else? Probably coordination between technologies, and the list goes on and on. And energy, as we know, is only one part of the challenge. Some of the most difficult emissions come from industrial production and food systems. And that brings me to the next question, because your book looks beyond electricity and transport to technologies that could reduce the impact of steel, cement, chemicals, materials, and food productions. These sectors are often described also as hard to abate because their emissions are embedded in industrial processes, heat requirements, agriculture, and complex supply chains. So which carbon materials and alternative food technologies look most commercially viable today, in your view? And also, where do cost, scale, infrastructure, or even customer acceptance still create real barriers?
Yeah, let's look at those hard-to-abate industries. And the ones that I focus on in the book, because they're so significant, are steel, cement, chemicals or plastics, and then together actually building materials and textiles. So if you look at what we might generally call green steel, the most easy to adopt actually is electric arc furnace technology. It already exists. It has for a long time. And this is technology that allows us to use recycled steel. And actually that has been growing. It's roughly a third today of all steel. It can really cut emissions significantly. You can go one step further to genuine, what I would call green steel, which is using green hydrogen to create the heat that's needed to process steel. And green hydrogen, of course, is hydrogen made with renewable energy in that production process. And if we use a combination of these technologies, we can actually reduce the emissions of carbon dioxide by 85-90%. So that's really significant. And given that the world continues to grow economically, particularly emerging markets, the demand for steel is not going down. And so we need a good solution to this. And I think we have it technically. The price is still a problem. It's probably, there are versions where you can nearly get price parity, but there are other versions where it's maybe 3 times as expensive. So I think we have an issue there. If you look at green cement, here, again, we have the technical solutions. This is mainly about decreasing the amount of clinker to cement, and we know how to do that. We have a version of that called LC3, and that already, even if we just use that existing alternative, cuts CO2 by up to 40%. Again, it's a case of driving adoption, and as you drive adoption, you also bring down the costs. In green chemicals and green plastics, typically bioplastics, the issue here is that it's very hard to compete economically with virgin plastics made from fossil fuels. So bio-based plastics, we know how to do them. Things like PLA and PHA. They can cost significantly more, between 2 and 8 times more. But some of these alternatives have a 75% lower carbon footprint. So again, it's worth pursuing, but it's a harder one because the chemicals industry is so locked in to the fossil fuels industry, and they've got those costs so low that at the moment it's still very hard to compete. And then if I just briefly touch on 2 of the others in the materials space, the one is bio-based building materials. So something like cross-laminated timber, so using wood as a substitute for steel and cement, can have, again, massive reductions in carbon, up to 75%. And we know how to do this. I do some teaching in Finland, and one of the cases we use there is a company, called Stora Enso, which works with wood as a building material. And, they're able to demonstrate now that they can make wood as strong or stronger than steel. So, the technology has really moved on. The last one is bio-based textiles. And I think, this is where we're looking at substituting those synthetic fossil fuel-based materials, things like, polyester and so on. So this, I would say, is still much earlier. We do have alternatives like mycelium-based leather, or things we've known for a long time, using hemp in linen and things like that. But again, here the fossil fuel industry has got those costs so low for things like polyester that it's very hard to compete at this stage economically. So let me pause there. Those are the main sort of materials that we might need to change.
I also digress that we had the owner of a German company that actually builds from scratch, constructs data centers only using timber. Before I had him as a guest, it also boggled my mind at first when I've heard data centers out of wood. Of course, fire hazard and all that stuff, but you've got techniques, as you mentioned. It's almost as durable as steel, in some cases maybe even more. Plus, with the proper protection, the fire hazard is even lower than in standard traditional data centers. So that was a very good example. And also, I would like to go back for a moment to the steel, because probably that will be a very good example. As you said, currently, the green steel cost of manufacturing it's 3 times higher than traditional steel. But do we have any success stories? Do you have any examples of big projects that already used green steel?
Yes, we do. This is where the Scandinavian countries have tended to lead. So the big company really is called Stegra. That's really producing the green steel, and they are supplying the market. The biggest company that's probably using it is Saab, which is big motor conglomerates. So, some brands have actually, made the claim that they produced cars that are 100% green steel. So we do know it's it's possible. It is one that has struggled, I think, partly with lack of funding, partly with a lack of adoption by the users, because you need the demand also to help push the supply. And we've seen a few big high-profile cases where some of those companies we were hoping would be the breakthrough companies have stalled along the way. That's normal in innovation. But it does mean that this one is moving slower than we would like.
That also highlights an important reality that technical performance alone is not enough. A solution must also fit into existing operations, supply chains, regulation, and customer behavior. And I would say also the same applies to digital technologies, where the potential benefits can be substantial, but unfortunately are not automatic. And your book presents Earth information systems, robotics, and artificial intelligence as technologies that can help monitor environmental change, improve efficiency, verify impacts, and support better decisions. So I'm really curious to hear where you think AI and digital monitoring tools are already delivering measurable sustainability benefits, and where businesses may be expecting too much from them at the moment.
Yeah. And just to be clear on also what I mean by Earth information systems, because people may be more familiar with GIS, geographical information systems. Earth information systems just sort of take it to another level, and there are really three types of Earth information systems. One is observing the Earth from satellites and getting all kinds of high-resolution data, both visible and invisible, and that's of course come on in leaps and bounds, particularly since what are called cube satellites were innovated and started to scale, very, very cheap and small, and are giving us now lots and lots of data. The second type is climate intelligence, and this is more around taking some of that data, but doing very sophisticated modeling. And of course, we're familiar with some of those global climate models. Sometimes, it's at the level of weather, but we're more interested in climate, that sort of longer term global forecasting. And then the third is actually at the micro level, and that's the whole area of environmental DNA, or eDNA. This is biodiversity sensing, where we can now take a drop of water from a stream, and by looking for trace elements of DNA, we can tell the biodiversity that's in that area. And there's a very new technology now where they can even do that with a sample of air, for example, above a forest. And so these are definitely starting to give us very, very powerful information. Where that's leading to is the idea of a planetary digital twin. We're familiar already, I think, from the fourth industrial revolution with the idea of digital twins, where you might have a digital replica, say, of a Boeing aeroplane, or of your factory, or of your body, and you can model with that and figure out the best efficiencies. And because we have so much data coming in now, we can start to do that at a planetary level. Microsoft already has what's called an Aurora model, which has 1.3 billion parameters that it's taking into account in that digital twin. And then the robotics and the AI. So I would say where, if I try to make it a little bit more practical, where we're seeing the benefits already, on the Earth information systems, we're getting very good data on things like deforestation, and so we're much more able to respond quickly to any illegal of cutting of forests that's happening. It's helped, for example, Brazil actually cut the rate of deforestation in the last 5 years. And we're also getting very useful information like methane data. So there's a methane satellite that can tell us where there are methane leaks. And as you know, methane is a more powerful global warming gas than carbon dioxide, up to 80 times more powerful. And so those two, I think, already are promising. And the eDNA is much earlier, but of course we start to get a better sense of biodiversity. On the robotics and the AI, the robotics, it's interesting when people hear robotics, of course, they think of humanoid robots. That is coming for sure, but that's not really where the early advances are. I would say autonomous drones is far more where we're starting to see benefits. We're using them not only to monitor pollution, but also to do things like drone planting, rapid reforestation of inaccessible areas. And then also, of course, delivery robots, not necessarily drones, although we're starting to see those, but we see, autonomous robots now starting to appear in different parts of the world, and they simply are more carbon efficient than somebody driving around in a car making deliveries. They're kind of the last mile delivery problem that's being solved there. We will get to the stage, I think, also where humanoid robots will be able to help us with restoration of nature at scale in a way that's very cost effective, because the cost of labor with humanoid robots will come down close to zero. I think we will get that kind of scale. So suddenly everything that required a lot of labor and was expensive becomes possible. On AI, a whole podcast subject on its own, but just to say, we already have many examples. I'm less interested in how it's being used, for example, to help companies do sustainability reports. It will be used for that, but this is not transformational. It's more specific applications. I'll just give you one or two to give, some practical angle
please.
to it. If you look at Blue River Technologies, they're now part of John Deere, and they work with AI for a form of precision agriculture where they can basically go over a field with their machines, and the AI, together with cameras, are able to tell for every plant that they go over whether it's a weed or a crop, and if it's a weed, exactly how much weedicide it needs, how much chemicals need to be applied. If it's a crop, exactly based on the condition, exactly how much fertilizer needs to be applied. And they claim that they can reduce chemical use by more than 80% as a result of that. On the circular economy, we have already AI-driven robotics now that can sort mixed waste with 99% accuracy. So all of that human error of putting the wrong things in the wrong bins, it goes away. We're able to very efficiently start to, sort and separate waste and make it recyclable. Just two small examples.
For me, it's very uplifting to hear that these are not technologies of future, but it's already happening. And as you said, people are already using it at industrial scale. So once again, very positive change. But also when companies use these tools, how should they deal with issues such as unreliable data, let's say limited transparency, energy use, and the risk of automating poor decisions?
Yeah, look, I think this is what business is actually good at, is dealing with risk, because in practice you never have perfect information. So, I would just say you need to apply the kind of risk models that you have for all your other investments and all your other tools that you use also to these new technologies. But I think, it's a little bit more about the perspective they should take on these technologies. Do you want to be a kind of early adopter, a late adopter? There's first mover advantage and first mover disadvantage. So I think strategically companies have to take a position and say, do they want to lead this charge or do they want to follow? And both has pros and cons. There's a very big upside if you're an early adopter and you get it right. But of course, there are also many who fail. So I also think this is where a collaborative approach is important, to think about technology not always as being one company developing and owning one technology, but to start to think about open innovation, to think about collaboration with technology creators and service providers, and to try to create an ecosystem around you of technology support, so that you're not doing it alone. Sometimes you might get into a coalition, either within your industry or cross sector and cross competition. So multi-sector, if you like, just to spread that risk and to make the advances. And as we're seeing with AI now, in the Chinese approach, there's actually a big advantage in open sourcing and saying, look, it's not that we're just going to license this to you and you're going to pay forever more and we can cut it off whenever we want. That's the American approach. Actually, we're going to, deliver you enough open source information that you can take the basic technology from us and then build on it, adapt it, and implement it however you may want to, and you own that technology then. And I think they are seeing already strong interest from emerging markets because, of course, they want that flexibility.
And that's probably a very important point, especially for ESG and sustainability teams. And I would also add that better technology does not automatically mean better data and insight. Once again, the data, assumptions, human judgment behind is something that still matters. And these tools can also bring their own environmental and social trade-offs. And that brings me to the next question regarding the shadow side of climate technology. I would frame it this way, because you deliberately examine both the positive and negative impacts of technologies in the book. Renewable energy systems, batteries, electric vehicles, and digital infrastructure depend on minerals, manufacturing capacity, land, water, energy, and global supply chains. They also create waste and potential human rights concerns, unfortunately. That being said, how should companies evaluate these trade-offs without presenting clean technologies as impact-free, but also without using their limitations as a reason to delay action, unfortunately?
Yes, and I'll pick up on the last point you made as well, which is about data. If you have rubbish data going in, you have rubbish data coming out, right? So the quality of the data, especially when you're thinking about AI, is really important. But also, the point you made is data doesn't necessarily translate into action or reduced impact. We've had a lot of ESG type data for a long, long time. I often catch out my students that I teach. I ask them when the greenhouse effect was first discovered, and they make their guesses, but actually it's over a century ago. It was 1896. So, we have a lot of the data, but that doesn't necessarily translate into action on the ground. And that's what we have to judge it by. Is it changing what's being deployed and the impacts on the ground? Then on the dark side, every technology has a dark side. So although we present these as clean technologies, as green technologies, it's simply naive to believe that they don't have impacts. Of course they do. Every activity that we have, which is an economic activity, and every technology we use has its negative impacts. And often these are resource impacts in terms of the technologies we're talking about. As you mentioned, can be physical resources, can be water, and can be pollution. And then, of course, they all have energy impacts as well. They take energy to make. So the approach to this has to be, almost like a cost-benefit analysis. We have to look at the impacts, the negative impacts, and first ask the question, are they less than the benefits? And in all the technologies that I've examined, they are fundamentally less. So the benefits of going for renewable energy or electric vehicles or precision fermentation or cell-based meat, all of these things are significantly better than the negative impacts. But then it's also not to ignore those negative impacts. So the second question is, can those impacts be managed? And this is something that people in business will be very comfortable with because, all the other technologies they've ever used have had impacts and we've had to manage them. So how can we best manage them to bring those down, to reduce the risks, to make sure that we have control on the supply chains, to also continue to innovate. This is also a mistake people make, is they assume that what technology we have now and the impact that has is what it'll always be. In fact, that's very, very seldom the case. All technologies get more efficient. We even saw that with AI when the Chinese DeepSeek model came out. It was many, many times more efficient than the American models. And we see that as well with batteries. The improvement in the efficiency has just been staggering. So on many of these technologies, we are in the equivalent stage of where Henry Ford was with his Model T, and the internal combustion engine. There's so much innovation that will come which will help us to reduce those impacts. But we have to have that transparency on those impacts. We shouldn't be in denial. But we have to also put it into perspective. So the media likes to focus on the negative impacts and in a way knock down those technologies and say, what about critical earth minerals? What about, the water impacts of data centers besides the energy impacts? They have those impacts, but they are manageable and they should be kept in perspective. Electricity on data centers, it's around about 1.5%. And so, yes, it's big, but, and it is growing, but there are many, many other uses of electricity that are much, much higher, that we could have much faster improvements if we got more efficient there. So that's my perspective on the impacts, is identify them and then look for those solutions. Renewable energy, creates a waste problem. Solar panels, batteries, and wind turbines. But we have solutions. We're starting to see that they can be recycled, and then we need to put in place the system to make sure that happens.
That summarizes it very well. And I would also agree that, yes, exactly. I can't think of any industrial system that is completely impact-free. But for businesses, for companies, the real question, I would say, is which option delivers the best outcome in practice. Because once again, for businesses, the challenge is turning that into a clear decision-making process. So let's suppose a company is considering a major climate technology investment, a procurement contract or partnership, and you're advising them. What questions should its leadership, procurement, finance, and sustainability teams ask before making a decision?
A couple of questions. The first is, does this address a global challenge, which is big and getting worse and something that is not going to go away and we have to solve? If yes, then we need to consider it carefully. Second question, is it either already scaling or showing the potential of scaling? And are the cost curves coming down in a way that we would expect that even if it isn't on price parity today, that it will be within a few years, in which case, probably worth being one of those early adopters and those investors. And then I think it's a case of building the business case yourself. So saying, okay, so what are the benefits to the business of adopting this? And often it's not just about the cost of the technology, it's about all the other efficiencies that it brings. So you can often reduce waste, you can reduce your consumption of resources, you can inspire more loyalty among your employees. They want to be working for a company that they can be proud of. You may be reducing risks in your supply chain. So you build a business case then around it, which we've had to do in sustainability anyway for many decades, but now you do it around specific technologies.
And more specifically, what should companies look at before committing to a technology? And also, how can they avoid backing one of those technologies that may never scale?
Yeah, I think obviously there is a risk in every investment. And one way, of course, is you can try to spread your bets. So not go all in on one particular solution, one particular technology, but invest in multiple, and then just watch how they develop and what they deliver. But I think what I would say is just look. Don't only look at your backyard. Don't only look at your market or even your sector, but look for the evidence of how these technologies are doing in other markets and in other sectors. And then I think you'll often find the evidence you need as to whether these are the right technologies to back. To give one example, Japan for many years has been backing hydrogen for mobility. So hydrogen cars, the hydrogen fuel cell. They've poured so much money into that. And maybe in the future there will be a role for that. But I would say if I was an investor now, very bad investment, because all the evidence suggests that, other forms of batteries at the moment, lithium ion, but, sodium ion is another competing battery on the rise, are just completely out competing that, and they're delivering and they're being adopted. Whereas the adoption of the hydrogen fuel cells has remained very small, and there are all kinds of problems with it about safely storing it and so on. So look at how it's been deployed in different parts of the world and whether it's achieved the traction. And if it hasn't, then maybe think twice. The last thing is just back to what kind of company you want to be. Do you want to be a leader in the space, or do you want to be a follower? So there are some technologies where you want to say, we can't be certain, but it looks like a really promising technology. We know it reduces the impacts, so we're going to put our efforts behind it, put our investment behind it. Something like regenerative agriculture, right? Big brands like Unilever, Nestle, Danone are massively scaling that. Now, there's still a debate out there of, can it work for all kinds of agriculture, and, can the costs compete and so on? But because they want to be leading in this space, they make that bet. And it may be that down the line they have to say, well, okay, we're going to also back something else like cell-based agriculture or microbial precision fermentation, put more investment into that because that seems to be delivering better. But you have to show leadership is the point.
Thank you very much for those examples. I think that this perspective will also, at least should give companies a more practical way to assess these decisions. I would also say that it shows why sustainability teams cannot do it alone. Finance, operations, procurement, risk, compliance, and leadership. So all the teams, they all need to be involved. To finish, let's look at what may change next. You describe technological change as non-linear. with falling costs, market diffusion, policy support, and positive tipping points, sometimes causing adoption to accelerate much faster than expected. Over the next, let's say, 3 to 5 years, which developments do you believe businesses should treat as credible and invest around now, and which widely discussed technologies still require patience or caution?
Yeah, well, if you look at the 20 technologies that I profiled, the ones that are no-brainers now are the renewable energy technologies, solar, wind, batteries, and EVs. I think the ones that are pretty safe bets and potentially very transformational, if you're linked to that space of food and agriculture, would be precision fermentation. And there's a lot more we can do on plant-based alternatives to protein. Cell-based meat, cell-cultured meat is one that has huge potential, is making progress, but I would say we have to be patient. We have to, get it, from the pilot plants where it is to really show that it's viable in the market. Same with some of the hard to decarbonize sectors, green hydrogen, green cement, green chemicals, and plastics. I think these are ones where the solution seems so compelling that we need to invest in it, but we need to be patient because it looks like they're earlier on in that adoption cycle. Some of the things like the big data from Earth information systems, again, a no-brainer. There's very little downside to that. Others are much earlier, like eDNA. Robotics, I think there's so many applications, so you will definitely find versions of that which are not necessarily humanoid robots, which will deliver great value for you even today. The humanoid robots treat with some caution for a while until they really prove themselves. And then AI, the big elephant in the room, you can't help but adopt that. And all the evidence I've seen so far shows that despite its resource impacts, the payback environmentally is many times more than the downside. So we will actually see energy savings and resource savings as a result of AI. So it will make everything more productive and more efficient. But I think the trick here is not to think that it can do everything, and really to look for which types of learning models. Do you need large learning model? Could it be a small language learning model? It's look for tailored AI to your specific industry, sector, and products and technologies, and it will definitely bring you the returns. But not if you just take a kind of blanket approach to just trying to adopt it for everything, or to just think that it's a chatbot. It's so much more than that. So those are the ones I would say you need to move on, and some to be cautious of.
Got it. And now, $1 million question. How can a company prepare for major technological change without wasting money on every fashionable new solution?
Well, this is a lot about, how does a company be innovative? And, firstly, if you're always reacting, it's always more expensive and you're never going to be the leader. So you have to actually make space for investment in research and development, as we traditionally called it, or innovation, experimentation. So you have to carve out a budget for that. And that means you also have to experiment. And I think that's the key, really, is can you have a space within your business where you allow that experimentation so that you can test all of those different options and see which ones are a fit for you, which ones look like they will be feasible, cost competitive. you also have to do a lot in terms of changing the skill set in your organization towards people who are far more agile. And this has a lot to do also with a corporate culture. Are you a corporate culture that is basically like a giant that moves very slowly, has lots of rules, lots of barriers to change, punishes people for failure? Or do you create a culture where you allow people to fail, where you encourage people to experiment, and then ultimately, you get those breakthroughs?
So, in a nutshell, I would summarize it for companies that, of course, early adopters, they always have to take some risk, but most probably they will have the cutting advantage in the market, right?
Yeah, exactly. I think if you want to be a leader, you have to take that chance, and the return can be, can set you up for a very, very lucrative, being a lucrative market leader. But it comes with risks. So again, you have to think about, if it's core to your sector, to your business, then it's probably, worth taking that risk to say, look, I can see that this could transform my whole sector, or is going to. I need to get ahead of it. I need to be a leader. I'm going to go all in. If it's a technology that is not core to your business, but you can see reduces some impacts, is beneficial in a way, then you can afford to be a little bit more of a follower. You can say, let others test it first, and then once it's proved itself, then I'll also adopt it. So, if I'm not an energy company, then I might look at what energy solutions are proving themselves first and then adopt. Or if I'm not a food company, I probably still have catering, and I could make some really smart decisions in that, but it's not core to my business. So I'll look at what the technologies are and how they're performing, and then make my decision. So I don't have to be a leader. But if it's my core business, then I have to be, at that leading edge.
Understood. And of course, as they say, no risk, no gains.
Exactly.
Before
Exactly.
Before we close, is there anything important about technologies of hope that we have not covered, or any final advice you would like to share with our audience?
I think it's just to re-emphasize the message that we started with. The whole point of technologies of hope is not that we're looking at fantasies here, not that we're, wishing for a utopia. What we're saying is, take the technologies that are already out there, that are in various stages of advancement and deployment, and back the ones that are going to give us the biggest returns. And those returns will ultimately be economic, but we're thinking more in terms of returns to the planet, reducing carbon footprints, better for nature in a really dramatic way. So, this is not wishful thinking. This is based on some serious analysis and data, and lots of cases. One of the things I do in the book is look at who the players are for each of the technologies, and I rather playfully categorize them into giants, which are the big companies, obviously, unicorns, which are the billion-dollar pre-listed companies, wizards, which are the sort of technological innovators in a way, and then the hobbits, which are the small, the startups, that could break through and become the next giant. So I think it's helpful to have the full perspective.
And of course, as we discussed even before our today's conversation, you covered a lot of technologies in your book. So everyone interested in more details, we just encourage them to go and read your book, right?
Yes, absolutely. And follow me, stay in touch. Always happy to engage. A lot of the technologies, many of the cases and examples are already in Thriving. For those who can't wait, the book comes out later this year. And I'll also be covering it probably in my own podcasts. I have 3 podcasts. But yeah, just stay in touch. And of course, I'm also always willing to learn and to hear from people how it's going for them. which technologies they're excited about, and make this a kind of strategic dialogue as we go.
And we'll be looking forward to the publishing date. Wayne, thank you for joining me today and sharing your perspective.
Thank you so much.
This conversation has been valuable because it shows that climate technology should be assessed neither through blind optimism nor automatic skepticism. Businesses need to examine evidence, cost, scalability, life cycle impacts, market readiness, and the systems required for successful implementation. They also need to recognize that technologies are tools, and their ultimate impact depends on how effectively they are deployed. For listeners and leaders who would like to explore these subjects in greater depth, you can learn more about Wayne's work and his new book, Technologies of Hope and Earth-Saving Mission, as well as follow his research, teaching, writing, and other projects. You can also subscribe to the Net Zero Compare newsletter to receive our latest podcast, conversations, expert insights, sustainability news, and practical resources directly in your mailbox. You can find more interviews, articles, and practical sustainability resources at netzerocompare.com. Wayne, thank you once again for your time, and thank you to everyone listening to the Net Zero Compare podcast.